Okay, guys, what I wanted to do is go over real quickly, how do we turn your simple position versus time data into a V versus T graph? The motion detector does so quickly, we kind of lose sight of that. There's a little bit of thinking involved in order to do that. So let's look at just some generic position versus time graph data, or data that I've put up here. I just made the thing for an accelerating object. Your data won't be the same as this, but it'll be the same shape. This produces this graph, position versus time, and we see that curve up. Now we know that the velocity can be obtained by the slope, and each time the slope gets steeper and steeper and steeper. So to get velocities, essentially we want to be able to calculate the speed or the slope between each successive point. And that can be kind of cumbersome to do by hand, so we're going to use the spreadsheet. We also need to think a little bit about when we calculate that average speed between here and here and here and here, what time is it actually going that average speed? Because it starts off at zero, going zero velocity, and at this time it's going faster, it's accelerating, it's changing its speed the whole time. So if we get one slope, when was the object going as fast as the slope says? So to do that's pretty simple. First thing I'm going to move this out of the way, and I'm going to make a column and I'm going to label it half time. And what this means is that I'm going to figure out the times halfway between these, because that's when the slope's velocity will be valid. So I'm going to use a function to do that. And a function, I'm going to use equal. And then I just want to get the average time in between these. So I'm going to take A3 plus A2 and divide it by 2. Hit enter. That makes sense. The halfway time between 0 and 1 second is half a second. Now I don't need to keep doing that. I'm going to go ahead and get this special cursor. It's going to apply that to all of those. One thing I want to get rid of here, I pulled it down a little bit too far. This 5 doesn't make any sense. Delete that. Because what it's trying to do is it's 0 down here. So it's saying the average between the 0 data and 10 was 5. So these are all my half-time increments. The next thing I want to do is I want to calculate the average speed that is happening at that time. So basically I'm just going to calculate the slopes of each one of these line segments. So again, we're going to use the spreadsheet to do the grunt work. Equals slopes just distance divided by time. So in this case, if I look at my position or my distance information, it's a displacement. Here's one position. I'm going to subtract from that the previous position. That's displacement. Close off the parentheses. I want to divide it by time, the time that it took to displace that much. Here's the final time minus the initial time. Enter. Uh-oh, so there's a problem. Hold on. Didn't close one of these. So the average speed for the first time increment was 1 meter per second, according to this, 1 centimeter per second on my scale. I'm going to drag that down. It's going to apply everything there. And look what it does. It calculates essentially what did it do? Made the slope of each one of these little successive places. Now, why is this important? Because now I can get an accurate V versus T graph. If I just take this and I plot our regular scatter plot, I get something that's linear. And from here, you should be able to find the acceleration. All right. Hopefully this helps. Let me know if you have any questions. Bye.